Hello viewers, welcome to my channel. So today we'll talk about how the live streaming works. So before getting to know about how live streaming works, let's get started and get to know what is live streaming. Suppose any live event is happening, like somebody is streaming from YouTube, Facebook, or even a live match is happening. So how that is broadcasted, right? Those are not pre-recorded. So what is happening in this case, the chunk of the videos, right? The events are happening and the chunk of the videos, like 10-second videos, are getting published to the internet in a high level, and from internet the client devices like laptop, tablet and mobile, they are fetching the video, and in their devices the video will be played. So this is how the high level it works. The video is not pre-recorded, so in this scenario the live event will send the video in the chunks to the internet, and from the internet the client devices will receive the chunk of the video, and from the client devices there will be a playback from the browser or any media player will play the video. So now we understood what is live streaming. So let's go and understand. In step one, basically we have to understand one concept here is encoder. Encoder is a different type of, we have an encoder and it can be called as a publisher as well. It kind of like a software encoder, or it could be a hardware encoder, it could be IP camera or web browser, WebRTC. So these are the different kind of encoders. So the software encoders are very common are the OBS. This is the open source software. From this open source software we can also record the audio and video. If you are not using the encoder audio and video capture devices, then you have to transport those particular audio and video to the encoder. And what the encoder will do, encoder will compress the video and encode the video. So why we need to compress the video and encode the video? Basically, why we need an encoder, right? One thing is here, without encoder also we can capture the audio video, right, from the camera devices, right, and from the web browser also we can capture the audio video. So why we need an encoder? So basically, if we don't encode the video and audio, then it will be the file size will be very larger, and it will be very difficult to transport that particular video file from one place to another place. And even if the one format is recorded, like it is recorded in format 1, right, so at the end if the user is not supported, the user devices might not support this particular format, so this could not be played in that the end users, right? So that could be also a problem. That's why we need an encoder. So encoder will help to compress the video. So during the compression it will eliminate the duplicate element, and it will reduce the size of the particular chunk, and it will encode in the different formats, so it could be understood by the end user devices. So what could be a encoded format? So very popular encoded format is H264. So this is a very popular encoded format. And when we say the software, what are the different software encoder apart from OBS, we have is a XSplit, Camtasia and Vimeo. In the first step, the videos are encoded with the help of encoder. So let's see what is the next step. So in the next step, the videos what are encoded by the our OBS software. So in this example we are taking the OBS software as an encoder, which captured our raw audio and video and which has encoded in H264 format. Next, what it has to do, it has to send that particular audio and video, whatever it has encoded, to the nearest edge server. So why it need to send to the CDN? Suppose we are doing the YouTube's live, right? So if we are doing the YouTube live, if the particular encoder software will try to send the audio video to the main server, it could be a very far from the user, right? And if we use the nearest CDN, so it could connect to this particular CDN and it could send the video. And how it will get to know to the nearest CDN? So we can use the DNS, right, or anycast routing. With the help of these two, we are able to find the nearest CDN, and that particular video will be sent to the nearest CDN. And while sending the video from encoder to the CDN, there will be a protocol can be used as a RTMP, that is nothing but a real-time messaging protocol, and that is built over the TCP. So it is very reliable and there will be no chances of loss here, right? And similar to the RTMP, we have a SRT, that is kind of a secure reliable transport protocol, and that is based on UDP. So in UDP we know there could be a data loss can happen. So this is in the second step. From the encoder, the video will be transported to the nearest edge server via using the protocol like RTMP or SRT. So in this example we will take the RTMP. So let's see what is the third step. In third step, the video are received by the edge server, nearest edge server. Suppose this is a YouTube edge server, right? Now YouTube edge server will be connected to the YouTube main server, and YouTube main server is connected via CDN server via the fiber channel, and fiber channel is a very fast connectivity between the server, so it can transport this video from fiber channel to the main server. So in step 3, what the main server will do? So main server will do the three tasks. So first task, it will do the transcoding. So while doing the transcoding, it is a compute intensive operation. It means many servers are involved doing the transcoding. So what happens in the transcoding? Basically the video whatever is received from the this particular OBS encoder, right? So that will be transcoded into the different formats like 360, 480, 720, 1080, 2040, like different type of formats that particular video will created. And after the transcoding, it will be transferred for the segmentation. So again, in segmentation also, it's a compute intensive operation. So there will be a multiple server will be involved in the segmentation. So in the segmentation, what will happen? So each video will be again divided into the 10-second chunks. Suppose there is a video of 360p, then there will be a multiple chunks of 10 seconds that particular video. So that could be like divided between the 10 seconds. So in the segmentation, the video will be divided into the 10-second chunks. And the third step after the segmentation, it will be sent for the packaging. So what will happen in the packaging? So in the packaging, whatever the live streaming protocol will support the format of the particular video, on that particular format the video will be packaged, like HLS and DAS, right? If you know, HLS is a HTTP live streaming protocol, and in that we have a manifest file, right, which have a detail of all the chunk of the video, and each chunk will have a ts4.ts format with the 10-second videos, right? And in the dash we have a .mp4 format of the chunk of the 10-second videos, and there is a manifest file which have all the details about these chunks and different formats. So this is the in the third step, these are the task of the main server. So main server first will do the transcoding, then it will send for segmentation, and after the segmentation the packaging will be done, and the packaging will be done in the format of HLS and dash. So let's see what is the next step. So now the video is in the main server, it is transcoded, segmented and packaged. Now that particular video will be sent to the CDN distribution and caching. So in this step, the video will be transported to all over the globe wherever the CDNs are present, and while transporting the video from main server to the CDNs, it will use the HLS or dash protocol. So HLS is nothing but is a HTTP live streaming protocol. It is developed by Apple in 2009, and dash is a dynamic bitrate streaming over the HTTP. HLS is a commonly used protocol because dash is not supported in Apple devices. So in this scenario, we will take the example of HLS. So we'll use the HLS protocol while transporting the video from the main server to the CDN network. So these particular video chunks will be transported into the many CDN networks in the step 4. Now what will happen once the video are imported to the different CDNs? So now in the step 4, the videos are imported from the main server to the all the CDNs over the globe. Now in the step 5, let's see what will happen. So in step 5, the CDN distribution and caching, in that step all the CDN will have the video, right? Now if the user want to watch the live streaming, right, so what will the user will do? User will query first the DNS will return the nearest CDN IP, right, and the user will connect to the nearest CDN, and when the user will connect to the nearest CDN, it will first download the manifest file. So manifest file will have all the details of the 10-second, right, chunks, and from where to download it according to the user bandwidth. It will suggest the whatever the resolution it has to download it. According to that, it will download the particular chunks, and after the downloading, the video segment is decoded, decompressed, and playback whatever is built in the browser or the media player will play the video. And if you make the selection like you want to see for 480 pixel, then it will will download only the 480 pixel chunks. So like that it happens. So in the overall, if we see conclude this, so first the raw video and audio will be captured by the encoders, right? Like OBS software or any third party camera can also record the video and it will send it to the encoder. Encoder will compress and encode the video, and then it will send the to the nearest CDN networks via the RTMP protocol. And once the CDN network receive that particular video chunks, right, it will send to the main server via the fiber channel. This is a very fast connectivity between the CDN to the main server. And in main server, there will be a transcoding, basically different type of format of that particular video. And after that transcoding, it will be done for the segmentation. Basically 10-second chunks for each format video will be created. And once the segmentation is done, it will send for packaging. Basically the HLS and dash format of the particular video will be created. And then from main server, the video will be transported for the CDN distribution via the HLS protocol or the dash protocol. Once the videos are available in the CDN, then user can query to the DNS, get the nearest CDN, and then it will download the first the manifest file. And in the manifest file will have the all the details of the video chunks. It will download the particular segment, right, and it will decode it, decompress it, and play back the video. So this is all over how the live streaming will work and how it will be implemented internally. And this is the all about the architecture of the live streaming. I hope you like the video. Please do subscribe my channel to get to know more about the system design.